Hello viewers, welcome back to the channel. In this video, we are going to be learning IPsec VPN. So we have a scenario here. Here you can see we have site 1 and site 2. So the site 1 which is the yellow and the site 2 the blue one. So basically IPsec is used to encrypt VPN tunnels. Okay. So here this is our VPN tunnel, which is the logical tunnel, not the physical tunnel. This is a logical tunnel, and this is our tunnel network 172.20.1.0/24. And the tunnel source 1.1.1.1 and the tunnel to destination 3.3.3.3. Okay, so here we are going to create a VPN tunnel between router 1 and router 3. Then we will use IPsec to encrypt the tunnel, and also we will see the packet flow on Wireshark. Okay, let me start the Wireshark packet capture. Okay, now we are capturing traffics on the links between R1 and R2 and R3 and R2. Okay, so now the Wireshark is running, and we have two PCs on site 1 and also two PCs on site 2. So here you can see the local area network IP network address 172.200.1.0 and the site 2 local area network 192.168.1.1 and the WAN network here 100 and 200 networks. So this is our scenario. So I think I need to change. I need to change the tunnel IP because site 1 has 172.200.1.0. So I cannot use the same network here. So I'm going to delete this. Then I'm going to add a new network here. So I'm going to use 1.10.10 network here. So let's say 10.1.1.0/24. So this is going to be our tunnel network. Okay, so let's go to the configuration file. So before, the purpose of IPsec is to encrypt VPN because now the site 2 and site 3 want to send their information securely. So which means the R2, let's pretend that the R2 is the attacker. So he is the attacker. So now the information between R1 and R3 is traveling via R2. So the R2 can see the data. So in order to prevent R2 from tampering our information or data, now we are going to encrypt the data. So the R2 cannot see any information. Okay, so that is our purpose. So we want to secure or encrypt our data. Okay, so let's go to the configuration page. Here, this is R1. I have already done the basic configuration. Let me show you the interfaces. Interface, so sorry. So IP interface brief. So here all the interfaces, first Ethernet 0/0, then first Ethernet 0/1 and loopback 0. This is going to be our tunnel source. Then show IP route. So here we are getting one network, two network, 100 network, three network, and 200 network. Okay, so before creating VPN tunnels, we have to check whether we have end-to-end connectivity. So the tunnel source and destination should be pingable. So they should ping each other. So ping 3.3.3.3, and here you can see the success rate. And now we have end-to-end connectivity, so we can create VPNs. So config T. So to create VPN, I'm going to enable. So now we are going to create tunnel VPN tunnel interface tunnel. Let's name the tunnel 1. So interface tunnel. state is down. So I'm going to assign an IP address to the tunnel. IP address dot 10.1.1.1. Then the subnet mask is 254.2, sorry, 255.250.255.0. Okay. Then tunnel source. Okay, tunnel source is 1.1.1.1. Tunnel destination is 3.3.3.3. Then tunnel mode. We have two modes, IP and GRE. So if we use IP, only layer up to layer 3 will be encrypted. So okay, so which means up to layer 3 header we will have this called encapsulation. Okay, so encapsulation up to layer 3. If you use GRE means layer 3 header, also TCP or UDP, also encapsulated. Okay, so I'm going to use GRE IP. So it's better to use GRE. So next exit. Next go to R3. So on R3 we already have end-to-end connectivity. So let's create the VPN tunnel interface tunnel 1. Then IP address is 110.1.1.2. Let's say 10. 255.255.255.0. Tunnel source is 3.3.3.3. Tunnel destination is 1.1.1.1. Then tunnel mode GRE IP. Next it. Okay, here you can see state is up, and also on R1 here is up. Let's try to ping the VPN tunnels. Okay, so I'm going to ping 10.1.1.1.10. Now I'm able to ping. I can ping 10. Let's ping from R3. Let's try to ping 10.1.1.1. So now the VPN tunnels are functioning. So far we have created VPN channels here. Here from R1, the tunnel source is 1.1.1, and tunnel destination is 3.3.3. On the perspective of R3, the tunnel source is 3.3.3, and the tunnel destination is 1.1.1. And here is our tunnel network 10.1.1.0/24. So VPN channel has been created, and it is functioning now because we have already checked. Okay, so the tunnel is functioning now. Now we are going to create IPsec profile. Okay, so now we are going to create IPsec profile. So IPsec has two phases. So now phase 1. So phase 1, we are going to create crypto ISACMP policy, IKE crypto policies. So crypto ISACMP policy. Okay, let's name the policy 1. Okay, so under policy, we are going to give the policies. Okay, so first encryption. So the options we have DES, triple DES, and AES. So we have 3 keys here. So these are encryption keys. So I'm going to use AES. So I'm going to use encryption key AES. Then hash. We have MD5 and SHA for hash function. So I'm going to use hash SHA because it is latest and more secured one. So I'm going to use SHA. Next, authentication. So we have pre-share, RSA, and RSA. So Diffie-Hellman is not available here. So I'm going to use pre-share now. Next, group. So group, this is our asymmetric key. So Diffie-Hellman here is our Diffie-Hellman group. So I'm going to use group 5. This is our asymmetric key. Next, life. So lifetime. So the range is between 60 to 86,400. So I'm going to give 1000. So policy has been created now. So on R1, so on site 2, the ISACMP policy, AKE crypto policies has been created. So let's go to site 1. So here the same IKE policies. Okay, so the same IKE policy, remember this, the same, everything should be same as the site 2. Okay, second P policy name, then encryption, AES, because we used AES on site 2. So then authentication, okay, use authentication pre-share, then hash, we used show over there. So here also I'm using show. Then group, we used 5 over there, so I'm also using 5. Then lifetime 1000. So everything should match. Okay, so same IKE policies. Next, we are going to create crypto IPsec key. So now we are going to generate a key over here. So now we have to generate keys. Okay, so we are going to generate a key here. IPsec. Let's give key. Okay, so key. So 0 means unencrypted password will follow, and 6 specifies an encrypted password will follow. So we need encryption. So I need encryption. So I'm going to give 6. Then the hidden user password string. So this is our password. This will be our password. So I'm going to give my name here, Kavi. Next, address. So we can give host name or address. So I'm going to give address. So the address, which is our peer address. So okay, so peer address. So our peer is 1.1.1.1. So our tunnel destination will be our peer. So here the tunnel destination is 1.1.1.1. So we have generated a key on site 2. Let's go to site 1. Here we are going to create a key, a second key, then 6 means encrypted key will follow. So Kavi, here also I'm going to give Kavi. Then address, here our tunnel destination is 3.3.3.3.3.3.3. Okay, next, so phase 1 configurations has been finished. So let's move to phase 2. Okay, so on phase 2 we are going to create crypto IPsec transform set. Okay, so let's give crypto IPsec transform set. So I have to give a name here, transform set name. So here also I'm going to give my name, Kavi, and this is our transform set. So we have ESP, AES, ESB, DES, MD5, null, seal, SHA, HMAC. So these are phase 2 encryption. So encryption protocols. So encryption keys, and so I'm going to use ESP, AES. Okay. Then we can specify key length. Okay, so 128 bit, 192 bit, and 256 bit. But I'm not going to give any specific value here. It will take the default value. So ESP show HMAC. So transform set using ESP. So we have ESP and AH. AH means authentication header, and ESP encapsulation security payload. AH provides integrity alone, but ESP provides integrity plus encryption. So encryption plus integrity, so double protection. So I'm going to go with ESP. So ESP show HMAC, and the command is done. Okay. Next command is mode. So I'm going to specify the mode here. So we have 2 modes, transport mode and tunnel mode. Actually, we have 3 modes, transport mode, and tunnel mode at traversal. So, but here we have only 2 modes. So transport mode means the original IP header is not encrypted, but in tunnel mode, the original IP header is encrypted. So this is the difference between transport mode and tunnel mode. So I'm going to go with tunnel mode because this is the more secured one, because the original IP header is encrypted. The original IP header, which is going to be the PC's IP header. So I don't want to, I don't want to anyone to see my original IP header. So I want hide everything. Okay, so I want to hide everything. So I'm going to go with the tunnel mode. Okay, so let's exit from here. Then I'm going to create crypto IPsec profile. So crypto IPsec profile. So I'm going to name Kavi here. Next. So now we are going to assign the transform set which we have created in the IPsec profile. So we are going to attach the transform set with the IPsec profile now. So set transform set. So we have already created the transform set, which is Kavi. So let me show you. Let me show you this transform set here. The transform set name Kavi is already created. So now the transform set is attached with my IPsec profile Kavi. So site 1 configurations are done. Let's go to site 2. So here crypto IPsec transform set. So here also I'm going to give Kavi. Then same transform set, I'm going to use the same transform set here, ESP AES. Sorry, then ESP AES, then ESP show. Exit from the here. Let me go. Transform set Kavi. Okay. So let me remove this command first. Okay, so restart keeper address. Okay. Exit. Okay, so crypto ISAC sorry, crypto IPsec transform set name Kavi and the transform set AES ESP AES then ESP show HMAP. So then in mode tunnel mode. Okay, so then exit from here. Next crypto IPsec profile same name Kavi. Then set transform set Kavi. So transform set. So IPsec profile is created. Okay, let me show you the commands. Show run. Okay, let's verify that all the commands are given properly. Here you can see the phase 1 policy, then the key, then crypto IPsec transform set, then IPsec profile. So IPsec profile is created. Let's assign the profile on the tunnel interface. Okay, so interface tunnel 1. So tunnel protection IPsec, then profile name. The profile name is Kavi. Sorry, profile Kavi. Okay, here you can see ISAC is on. Okay, let's go to R1 interface tunnel 1 tunnel protection tunnel protection IPsec profile Kavi. So if ISAC is on, show IP interface brief. Here you can see our tunnel is still up. Interface tunnel IP interface brief. Sorry, show IP interface brief. Still the tunnels are up. So let's go to the Wireshark and verify whether here you can see okay, you can see the traffic. I can't see any IPsec traffic here. Let's see. No traffic. Don't know. Can't see any IPs. ISAC MP traffic on the link. Okay, let's get back here. Okay. let's see. Show IP root. Roots are okay. Okay, let's give IP route 192. Yeah, 72.200, so 20.1.0 connected via 10.1.1.1. Sorry, subnet mask is missing. Connected via 1.1.1. So give here IP root 92.168.1.0 to subnet mask 0.1.1.10. Okay, I'm going to ping from PC1 to PC3. So it's PC1 ping 192.168.1.3 cannot resolve. Dot 1.3 timeout. Yeah, you can ping from R1. Sorry, from PC1 to PC4, PC3. Okay, let's go to the Wireshark and see the traffic. Here can't see any traffic here, so which means the traffics are encrypted. Here you can see the IPsec MP traffic. Okay, I'm going to filter out the IPsec packets alone. Here you go. Here you go. You can see the traffic. So the IPsec is working now because phase 1 successful, identified authentication successful, and quick mode also successful. So now our data is encrypted. Okay, let's go to the next link. So here also I'm going to filter second P. Here also we can see the traffic. So first 4 packets are same packets. So repeatedly trying to connect to the peer. So first 4 packets are same packet. So first packet, second packet, third, fourth, fifth, sixth. So first, second, third, fourth, fifth, sixth. So 6 packets. These 6 packets. So 1, 2, 3, 4, 5. So these 6 packets are the main modes, belongs to main mode, and next 3 packets belong to quick mode phase 2. Okay, let's open this packet. Here you can see the security association. Okay, so security association, which is probably the first packet. Okay, initiator, cookie, responder cookie, version, identification main mode. Okay, let's go here. This is the main mode first packet. So first packet, first. Then key exchange, security association. So security association, so first packet. So now we can see the IPsec traffic here, source port 500 and destination port 500. So IPsec MP. So here, here we can see the security association IP profile policies. These are the policies we have created. So here we can see encryption AES key length 128. So it took the default value key length. Then hash show we gave. Then group 1536 bit length. Asymmetric key, the asymmetric key length is 1536. Then authentication method pre-shared key. Then life seconds 1000. So phase one, negotiation, NAT traversal in IKE. So tunnel mode, because we have used tunnel mode. Next, this packet, these two packets are main mode, first packet and second package. Okay, so same IKE policies. Here you can see the same IKE policies. Then here we can see the key exchange. So this is the key exchange. So they exchange their public keys here. Here you can see the key exchange and nouns. So nouns and key exchange is here. Next. Then last two packets are encrypted. So these are ID payload and hash. Then quick mode, all the three packets are encrypted. Let me show you. Here you can see encrypted data, 144 bytes. So data are encrypted. Okay, let me show you the data. Okay, so now I'm going to send some data from PC2 to PC3. I think we have already sent some pings. We have already sent some pings. Let's see the pings on Wireshark. So let's filter ICMP. Oh, ICMP. Okay, let's see whether we can see any traffic except. Okay, let's filter out ESP. Yeah, here you can see the traffic from 1.1.1.2, 3.3.3.3. Here it is encrypted because I can't see any of header like from 192.168 something. You can see only source from 1.1.1.2, 3.3.3. So which means our traffic is encrypted. So here you can see ESP encapsulating security payload. So our ping packet is inside the ESP header. Okay, so is encrypted. Our traffic is encrypted. So these are encrypted packets. See, so our traffic is encrypted. Okay, so ESP, we used ESP, encapsulated security payload. So our traffic is encrypted. So our motto is to hide our data. So now can't see any data because it is encrypted. So nobody can see my data over the any insecure medium, okay, called WAN. So my data is encrypted. So our data is encrypted because we have already saw that our data is encrypted. Now the site 1 and site 2 can have a secured communication over an insecure network. Okay, so now the attacker, the R2 cannot see my data because it is encrypted. So this is the motto of IPsec. Okay, so in this video we have learned uh, VPN creation, VPN tunnels, how to create VPN tunnels. Then we have also configured IPsec. Okay, so we have learned IPsec and VPN. So I have shown you how to create VPNs and IPsec and how to encrypt the VPN tunnel using IPsec. Okay, so I think this is enough for today. Okay, thanks for watching the video. If you like the video, please share the video with your friends, and we will see in another video. And thanks for watching the video. Bye bye.